Okay, we've got a vector addition problem where we're adding three vectors in 2 dimensions. So, as always, you should attempt the problem first before you view this solution and then see if you match up. I'm going to start with a diagram. Alright, so our three vectors, we've got vector A is 2.2 miles in a direction 23 degrees west of south. So I'll draw that one like this, where this angle is 23 degrees. I prefer to measure my angles with respect to the horizontal axis, so I'm going to draw that as well. Vector B is 3.2 miles south. So since the first vector was 2.2, I'm going to draw this one a little bit longer. And then vector C is 3.8 miles in a direction 28 degrees south of east. So that looks like that goes down like this, making an angle of 28 degrees south of east. Alright, so I draw those three vectors out. I'm sketching them out as best I can so that I have some idea of what the resultant is going to look like. I think my resultant is going to have a relatively small positive x component and a relatively large negative y component. So once we add up the resultant vector, we'll see whether or not I'm right. Alright, let's start with vector A. We'll break down vector A here. So again, vector A here makes an angle of 67 degrees with the negative x-axis. I'm going to break that down to x and y components. And AX is negative 2.2 cosine 67, or if you prefer, negative 2.2 sine 23. Either way, that's negative 0.860. And then AY is also negative 2.2 sine 67, or if you prefer, negative 2.2 cosine 23. And that's negative 2.025. So my sign convention, of course, is that I'm doing my typical Cartesian sign conventions, that north or up is positive, and east and to the right is positive. So west and to the left is negative, which is what our x component is, and south or down is negative, which is what our y component is. Alright, vector B should be easy. Vector B points due south, like that. So bx is 0, and by is minus 3.2. Easy enough. And then vector C points down like this, makes an angle of 28 degrees. So we're going to split that up into Cx and Cy. Cx is positive 3.8 cosine 28, which is 3.355, and Cy is negative 3.8 sine 28. Okay? I hope you understand here that Cx is positive because it points in the positive x direction to the right. Cy points down, so it's negative. All three of our y components are negative in this case. So that's step one. I've got all of my vectors broken down into components. Step two is to recombine those components, or combine those components. So my AX component of my resultant vector is 2.495, and the Y component of my resultant vector is negative 7.009, which is kind of what I figured when I started. I figured we'd have a relatively small positive X component and a relatively large negative Y component. Now the last step is to recombine my resultant. Again, if you haven't already done this, this is a good chance to pause the video and practice on your own recombining two components into a resultant vector, and then you can check your solution with me. So to recombine, I'm going to draw a triangle here with an x component, Rx, of 2.495, and a y component that is 7.009. And then here's my resultant. Now in this case, when I'm making my triangle, I'm only using the magnitude of Rx and the magnitude of Ry. I've already got the directions of both, right? Rx points in the positive x direction, Ry points in the negative x direction. So my resultant clearly is going to be some vector that points, south of east, I guess. I don't need to use negative numbers in my triangle. It's just going to mess up my calculations, as I'll explain here in a minute. So the resultant R, the magnitude of it is found using the Pythagorean theorem. That's 7.4 miles. And then the angle theta, well, we have tangent theta is equal to opposite over adjacent, which is Ry, the magnitude of Ry over the magnitude of Rx, or 7.009 over 2.495. So theta is equal to the inverse tangent of this ratio, which is 70 degrees. And we're 70 degrees, here's east, and here's south, so we're south of east, right? So there's the magnitude and there's the direction. Again, I'm not using a negative value in my tangent. If you use negative, like if you put a minus sign here in front of the 7.009, then your calculator is going to spit out a negative angle, negative 70 degrees. Which, okay, that's right in this case, but if you were over here in this quadrant, then you'd be given the wrong answer by your calculator. So I prefer to figure out where the vector is pointing with my diagram rather than letting my calculator decide. So I recommend you always use positive values here.